Okay, so let's talk about universal law of gravitation. Universal law of gravitation, the first step that you have to know is that it was proposed by Sir Isaac Newton. Okay, now what the statement, that is the definition of universal law of gravitation is that was given was every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So every body in the universe, this is in the universe, attracts every other body, every other body. So first, let's go step by step before going further into the definition. Say suppose you are over here and there is another body in the whole of the universe. Now it is applicable since this is universal law of gravity. This is universal law of gravity. So universal means it's applicable everywhere. Everywhere. So since this is applicable everywhere, so this should also be true in the surface of the earth. So now as you can see, say you are over here A and there's a huge ball B over here and there's a comparatively large ball C over here. So now due to this particular law, what we can understand is that this body attracts this body, that is a force F is generated because of this body in this particular body. Now I have used the term a force that is generated, that is a pull. A pull is being generated, gravitation. Now please keep in mind gravitation, pull, gravitation is always a pulling force. So this is what we have to keep in mind. Now coming back to this definition, because of this body experiences a pull. Now in my second case, because of this body B, body A experiences a pull. So if I write this F because of body B experiences a force, and because of body A, body B experiences a force. Now this is pulling this object and this is pulling this object. So this is what law of gravitation means. It does not matter whether this object is small or large. All that matters is that if a matter, now what is matter? Anything which occupies space and has mass. So anything which occupies space and has mass. So we can say to a certain extent that almost all of the particles in the universe has mass m, has a certain amount of mass m, no matter how negligible it may be, but still it has a certain mass m. So all the objects in the universe pull each other. They pull each other. That is what the law of gravitation tells us. Now coming back to our definition, every body in the universe attracts every other body. Now this is what we know, that there is an attraction. Now how does this attraction depends upon your direction and depends upon your distance plus also depends upon the mass of the body is given by this law in your later half. With a force, other body, this is with a force. With a force, now let's see what is a force, which is directly proportional to the product of their masses and inversely proportional to the square of the distance. Other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, so this is what the mathematical second law tells us. Every body in the universe attracts every other body, that we have verified. Now, what is this attraction? What is the value of this attraction? What does it depend on? This is answered by the later half of your definition, that is, with a force. It attracts with a force. This is the force. Now, what is the force? This force which is directly proportional to the product of their masses. Product of their masses, that is, if this is M and this is capital M. So the force is directly proportional to product of their masses, M into M. That is small m into capital M, and inversely proportional to the square of the distances. And F is inversely proportional to the square of the distance. Say suppose this object A and this object B has a distance of R. Therefore, by Newton's law of gravitation, what we can say is, first this is directly proportional m into m, and later on this is inversely proportional, that is 1 by r square. It is inversely proportional to the square of the distance. So in a way, we can now combine these two laws. Let's see how we can make this into a unified form. Now, this is object M and this is object capital M. Now, if the distance between these two, keeps on increasing, if this goes this way and if this goes this way, the gravitational pull will decrease. And how will they decrease? That is by the inverse of the distance between them. So we can combine F, as we know it is directly proportional m into m, and F is inversely proportional to 1 by r square. So by combining these two, we arrive at F is directly proportional to m into m divided by r square. And this is the mathematical expression of the Newton's law of gravitation. Newton's law of gravitation. So basically, all of your above definition comes down to this particular formula, and the meaning of this is F is your force. Now we have already discussed what is force. So if you have any doubt what is force, then please consult our previous videos. Now force, this is the gravitational force. Actually we are talking about the gravitational force. Okay. So once you're done talking about gravitational force, this is mass m. The force that exists between any two objects, the pulling force that exists between any two objects is m and m. That is the product of mass m and this m divided by r square. Now there is a question. Now what about why Say suppose we are in the surface of the earth. We are in the surface of the earth, and say suppose you are sitting near an object. So if you're sitting near an object, why does not this two attracts each other? Okay, now you have to know one thing. F is directly proportional to m into r square. So F is actually given by, that is F is equal to G into m by r square. Now we know that G is a very negligible quantity, very negligible quantity that we can neglect. Now we also have to know, that is one most important thing that we should know, is that gravitational force is a weak force. And that is the reason, even though, now you may ask me, even though it's a weak force, but still it should attract. The reason why it's not attracting you is because there are many other elements which stops its movement. For example, you are standing on a ground, so you are experiencing a friction, and therefore the gravitational force cannot overcome your frictional force, because friction is far greater. The second thing that you can notice is that you are surrounded by a envelope of air, that is an envelope of gas that you know as atmosphere. So due to atmospheric pressure also, you are not experiencing the gravitational pull, because atmospheric pressure nullifies the gravitational force that you face towards each other. The only thing that you experience is, because of law of gravitation, you experience that you are standing on the surface of the earth. A person over here is also standing on the surface of the earth, over here also standing, and over here also standing. So this is the pull. Now why? Because the mass of earth is huge. This is very huge. So the value of G, by mathematical calculation, scientists have arrived the value of G, the present value of G, to be 6.67 into 10 to the power minus 11. Now please notice that is in the order of 10 to the power minus 11. So you can imagine how small this can be. 10 to the power minus 11, that is Newton meter square per kilo square. G is equal to F into m into r square. So that is why F is for Newton, force is for Newton. That's why you have a unit of Newton over here. R square, R is distance, therefore meter square. We are talking about the SI unit. I'm explaining to you why do we have m square by kg square. And mass is denoted by, this is capital M, mass is denoted by kilo. So kilo into kilo, that is kg square. That's why this is your unit of gravitation. Now you can see that is 10 to the power minus 11. So the only pull that you will experience is because of a huge object like the surface of the earth. Earth is a huge object, and therefore only then you will experience a significant gravitational pull.